Hello everyone. Now the last part on how to actually use a SAT solver. I'm gonna be using this sat.gs, the one I shared with you. Feel free to use any other SAT solver, but the process might be a little bit different for different SAT solvers. And actually there is a tutorial here. So if you click on tutorial.cnf, then it will load this for you. As you can see, C is a comment. So C for comment. Any line starts with a C is not part of the program. It's just a comment on what's happening. B is an actual statement, CNF. 5 is a number of, you can think of like literals or variables you have. 5 is a number of clauses you have. So here we have 5 variables. So you can see 1, 2, 3, 4, 5. Anything that ends with 0 is just the end of clause, it's the end of the line. And we have 5 clauses. So 1, 2, this is all 3 because I don't have a 0, so it goes to the next line. So 3, 4, 5. And if you read this, it actually explains here that um, a clause is represented by a sequence of integers followed by a 0 and a new line. And a single clause may span multiple lines like this one. Okay, so this is like a tutorial on how to use this. I'm just gonna start a new one from scratch now. There are many ways to do this. I'm just gonna show you how I do it. So this is just a picture I sent myself of the solution we just did together. So this is the last CNF form we have. The yellow one is coming from circuit 1, the green one is coming from circuit 2, the blue one is a validity check. This is equivalent to as if we had an XOR gate, except we don't actually have an XOR gate. I actually got some questions about what if the number of clauses is different for circuit 2 and circuit 1. It doesn't matter. The number doesn't matter. This one could be 1 line and this one could be 100 lines. It does not matter, okay? We're just ANDing everything together, putting them in CNF form, and giving it to the SAT solver. And very quickly, we're expecting this to be equivalent, right? So we're expecting this to be unset. Okay, so I like to put a comment for myself. This is my equivalence checking program. Anything you want, like, you can put your name. So it's your assignment or your group name. And then I think we said we have 6 variables here and we have 14 clauses. You can see this in the previous video. So I can say, you can just sheet from here. It says B, CNF, I'm putting it in CNF. I have 6 variables, I have 14 clauses. Okay, and then I like to organize my, I think white space is good here, but we'll see. I have A, B, C1, D1, C2, D2. Okay, and then you can number them anything you want, but in order. So, you can make it A, C instead of A, B. You'll still have 6. It's just a way of conveying those variables into the SAT solver. I'm gonna call A1, B2, C3, D1 is 4, C2 is 5, D2 is 6. And then if there is a negation, it's just gonna be the negative value of that. Remember, this is all a comment. This doesn't actually do anything. It's just I'm organizing the code for myself. Okay, so now we can start with the first clause. I have not C1. Here I said that this is a comment, right? C1 is 3. Not is a negation, so -3. Not C1 or A is 1, end with a 0. Go to the next line. Not C1, so not 3, then -3. And, or here, not C1 or B is 2, end with a 0. Not A, not B, C1. Not A is -1, not B is -2, C1 is 3, end with 0. Right? And then we have not D1, B, C1. Not D1 is -4, C1 is 3, and B is 2. The order doesn't really matter because they are ORed together. And then we're just going to end with a 0. So now I have 1, 2, 3, 4. And then I have not B, not D1, not B, not D1, 0. Oh, it's D1 actually. So 4. And then I have not C1, or D1. So notes C1 is 3, D1 is 4, 0. Oh no. Okay, sorry about that. So I actually finished the first 6 clauses here. 1, 2, 3, 4, 5, 6. And just to save your time, you will need to enter all of them, right? For the circuits when they are not equivalent, and even now they will be different. But just to speed this up, I already know that the next 6 are almost the same, except C1 is replaced with C2, D1 is replaced with C2. So C1 is 3, C2 is 5, so I know every 3 will become 5. This is just a way for me to do this faster, but please take your time with doing this. Otherwise, any small issue will ruin everything. D1 is 4, D2 is 6. So I'm going to replace every 4 here with 6. And I'm only able to do this because they are equivalent, and I know that ahead of time. But, in general, we don't know, and we cannot do this. Okay, and then I have D1 or D2. D1 is 4, D2 is 6, end with 0. And then not D1 is not 4, not minus 6, end with 0. I'm going to replace all those. And then I'm expecting this to be unset because those are equivalent. And it is unset. So we're basically done. Now, again, this validity is very, very important. I told that those are not equivalent. I'm asking to check if this can ever be satisfied in such a way that the two outputs are not the same. And it says no, this will never be satisfied such that the two outputs are the same. What if I replace this with equivalent instead of not equivalent? It will basically be, this will be minus, this will be 1. So I'm saying, are those the same or not? Are those two outputs the same or not? Yes, they are, at least once. Are they always the same? I don't know. This doesn't tell you anything. So we're always checking validity, and it's always going to be like that. So when you're doing this kind of problem, please don't copy like what I did here. I knew what I was doing. You need to enter them one by one. You need to count the number of variables very closely. You need to count the number of clauses very closely. And if C2 will be different, so you need to actually do this very, very carefully for C2. It will get a little bit big, but again, it's very systematic. This might be too long, too big, but it will be very systematic, and as long as you enter it correctly, you will always get the correct answer. Thank you.